What's up, Bachelor Nation? This is Rex with TorchPrep, back again with some math questions from the Red Book. I'm in test 2, and I'm not on problem 15. I'm on problem 17. Let me erase that. So go ahead, pause the video. After you do so, read through problem number 17. When you're ready to listen to the explanation, go ahead and press play. Awesome. So number 17, it is a word problem. And I have a nice little diagram there for you of what we're talking about. I'm going to be using the word problem strategy. This question is not that hard, but it does deal with some complex fractions. It also, in a word problem, has a lot of content. So if that amount of content freaks you out and it's just going to slow you down, I would skip this in the survey, do it in the work portion. The second step of your 3-sweep survey of the math test. But if you are ready to use the word problem strategy, know that the math in here isn't all that hard. I know you can handle it. Either way that works for you, let me show the explanation right now. So basically in the question, we got this machine part, and we have these 2 bullseyes right here. That's going to represent 2 holes that are going to be drilled through this machine part. And what they're telling us is the distance on the diagram across the entire width of the part, but also they give us this important information. Both are on these 2 holes are on a parallel line with these lines of the width. Now, first step of my word problem strategy is, what am I trying to find? They want us to know what is the distance between both of those holes in the machine. So, what they've given us is that they exist on a line that is parallel to the edges of the piece. Also, one hole is 2 1/16 units from the edge. The other one is 4 3/4 units. Isn't that funny that 4 3/4 in my drawing is smaller than 2 1/16? This is math, not art. Don't judge me. So what we're going to do is we're going to take 11 5/8, that's the full length of the width of the piece, and we're going to subtract these 2 pieces here. That's how far away they are from the edges to find out what's the remainder here in the middle. But you're going to find as soon as we start our subtraction, we're going to run into a bit of a problem. So let's dive in here. Basically what we're going to be doing is 11 5/8 minus 2 1/16 minus 4 3/4. Now what I'm going to do here is I want to subtract each of these, but the problem is, as complex fractions, they do not have the same denominator. I can't simply subtract each one. So what I'm going to do is I'm going to multiply them times something that makes them all have the same denominator. Now remember, if I multiply something times 1, anything times 1 is going to equal itself, right? It's going to stay the same. Cool thing about that as well, you can always multiply something by a fraction. What if I did 15 over 15? You know what? That'll stay exactly the same, won't it? But I can change, if I have a fraction, what the denominator will be. Watch what I'm going to do. I'm going to find the number that these denominators fit into. That's the smallest and easiest to work with. And it's pretty simple. I have 8, 16, and 4 as my denominators. I know 8 can be multiplied into 16. 4 can also be multiplied into 16. So I'm going to convert these by multiplying them by 1, but with a specific fraction. What I'm going to do here is multiply 11 5/8 by 2 over 2. I'm not changing it. It's going to remain the same value, but it's going to look different. So the 11 can just stay the same because it's being multiplied by 1. But I can change this fraction into, what's 5 times 2? 10. What's 8 times 2? 16. Look, I now have these both in the same format. So I can keep this one the same because it has the largest denominator, 2 over 16. What about this one over here? I have 4 3/4. I want this denominator to equal 16. If I do 4 times 4, that'll equal 16. So I'm going to multiply this last distance by 1, which is 4 over 4. What I will get is the following. 4 will stay the same because it's just being multiplied times 1, but I will change the fraction to a different denominator. It will be 12 over 16. And now check that out. You have 3 complex fractions, all of them with the same denominator. So what you will find, let's do this first one over here. So if I want to do 11 and 10 sixteenths minus 2 and 1 16th, 11 minus 2 is 9. And then 10 sixteenths minus 1 16th, that'll be 9 and 9 sixteenths. And we still have 4 and 12 sixteenths. All right, so now we have to subtract the 4 and 12 sixteenths from that. And then what we will get is 9 minus 4 is 5. And then 9 minus 12 is actually going to go to a negative number. So we actually know this is going to dip below 5 and go down to 4. So I have 9 minus 12. If I take 9 away from it, I'm going to get down to 4 and 16 sixteenths. But I'm going to subtract an extra 3 from this. What is 16 minus 3? Equals 13. The answer is 4 and 13 sixteenths. If you look at the letter choices, that answer is D. Great job.